Well, good morning, everyone. Thanks for joining the webinar today, and we'll get started on time. And my name's Ray. I'm a senior product manager with Amazon Web Services. And today, co-presenting with me, we have Kara. Kara is a senior product marketing manager with Splunk. We also have David. David is an SVP of technology platform at TrueCar. So in today's webinar, we will have an overview of all the AWS Big Data services and different capabilities. And specifically, we'll go a bit deeper on the data streaming service here at Amazon Web Service called Amazon Kinesis. Then we'll have Kara give you guys a brief overview of the Splunk capability on AWS. Then we're going to hand the stage to David to talk about how TrueCar is leveraging both AWS and Splunk capabilities to gain insights from their data in near real time. And lastly, we'll have some time to open up for Q&A sessions. And as we go through the webinar, you can submit the question through the webinar panel. Okay, so put your data to work with big data services from AWS and Splunk. First of all, why should I choose AWS for my big data solutions and applications? First of all, it's immediately available. And you just go to the AWS console, provision the resource you want, or go to leverage the service you want to use, and all these resources and the capabilities are available to you right away, so that you can start building your analytics, applications, and solutions right away and not spending any time on any of the undifferentiated heavy liftings. Second is the broad and deep capabilities of AWS Big Data Services. From the next slide, you'll see we have a broad set of services that give you different capabilities from storage, analytics, visualization, data import, real-time streaming, and etc. And third, of course, data security is super important because you're leveraging AWS to analyze and store critical data of your business. And at AWS, we spend a lot of energy and resource on security so that we make sure when you leverage the AWS platform, your data is securely stored and analyzed only by you. And lastly, which is super important as well, is scalability. So as you gain scale with your business, your data volume is going to go up. And if you choose to use AWS, all of these big data services are designed for very large scale. So as you scale your business, your data platform, you do not need to redo your solution. So from the very beginning, you've set up for the success for the long-term data growth. And as I mentioned previously, at AWS, we have a broad range of different services for you to collect your data, store your data, and analyze your data. From an open source framework like Amazon EMR, from serverless compute like Lambda, data streaming like Kinesis, and different set of storage services based on your storage requirement. We have S3, we have Glacier, we have Elastic File System, and etc. And today's focus, I want to dig a bit deeper into streaming data service, Amazon Kinesis. So first of all, what is streaming data? Streaming data is really referring to the type of data that is continuously being produced and generated. And it turns out vast majority of the data in the world today, they are being generated continuously. For example, if you have a mobile application, your user interaction data with your app is generated continuously. So does web clickstream. As your customers go to your website and click on your website, all these events are generated continuously. Log data is another big one. All the application servers, web servers, they're writing log data to local server in real time and continuously. And also metering records, a good example will be AWS. So as our customers use AWS resources, we continuously meter the usage and calculate a bill for our customers. And then IoT use cases are another big one, or the IoT sensors, smart buildings. These data are generated continuously. But oftentimes, traditionally, we see customers analyze these data in a batch-oriented way. It's not because these data are not naturally generated continuously. It's because we only have this batch-oriented tool to start with. But now things have changed. We start seeing a lot more traction, a lot more involvement in streaming data technologies, which enable our customers to collect, analyze data in real time. Then why should I do that? Why should I care about it? Because it has been working fine for our business use cases so far. Why should I care about it? Well, the real reason is simply explained by this very simple graph. Because there's this diminishing value of data over time. So as time goes on, the value you can generate out of your data goes down dramatically. So for example, say you run a web server, and all of a sudden you're hitting a website issue. When your developers log on to your logging server, you want to make sure he can see the most recent log data right away so that he can start troubleshooting and fix the issue. And in the traditional batch-oriented way, you might have minutes or even hours of delay. So that really impacts the way you can leverage these data and gain value out of these data. And so we talked about, real-time processing. What are some of the core requirements and elements for real-time streaming data pipeline? So first capability, you got to have to figure out a way to ingest these data continuously at very large scale. Secondly, a lot of data is generated in a very raw form. You got to have to transform the data into a particular machine understandable way or with a particular schema so that you can analyze them later on. And once you analyze the data, figure out a pattern, you need a way to react to that data in real time. Then oftentimes afterwards, you also want to persist the data, the streaming data, for long-term storage and later on for historical analysis. So we really see streaming data as complementary to the traditional batch-oriented data analytics. So this way you can gain insights in real time, take real-time reactions, and at the same time store these data for long-term analysis as you always have been doing. And what are the key requirements for streaming data pipeline like this? First of all, you got to make sure data is durable so that you never lose any critical business data. Second and third, it has to be continuous and fast, because as I mentioned, the whole value proposition of a streaming data pipeline is you're able to react to the data quick enough in real time and be able to continuously process them. Another three elements: correct, reactive, and reliable. These are very common requirements and elements for data analysis pipeline. You got to have to make sure the result is correct. You got to have to make sure it's consistent and reliable. It always produces the same results by piping through the same data and the same logic. And also it has to be reactive, because in the real-time case, you wanted to analyze the data in real time because you got to have to react to the data in real time. At AWS, we have Amazon Kinesis services, and these are a set of services that offers different streaming data analysis capabilities. Today we have three services under Amazon Kinesis. The first one is called Kinesis Streams. It stores your data as a replayable, continuous data stream that enables you to write your own applications to process and analyze these data. You can use the Kinesis client library, which is an abstraction layer for you to process the streaming data out of Kinesis Stream. You can also use AWS Lambda function. You can use Spark, different kind of tools of your choice. The second service is called Kinesis Firehose. It loads the streaming data into different destinations, such as S3, Redshift, and Elasticsearch service. So what Firehose service allows you to do is you can configure data producers to continuously push in the data to the service, and then the data will be continuously delivered into these different destinations. So the benefit of this service is you still use the tool you've always been using, like a data warehouse, a search engine, or visualization tools. But in this case, instead of waiting for the data to show up on an hourly or daily basis, you get to have the data and make them accessible continuously with minutes and even seconds latency. The third service, called Kinesis Analytics, it allows you to use a standard SQL statement to query against the data stream. The key difference between a SQL engine on top of a data stream versus, say, a traditional data warehouse or a storage system is that you will be able to query the data much faster, often with milliseconds or seconds latency. And second, it's a continuous time window, because as you can imagine, as the data continuously coming in, it's actually a dynamic data stream. The time keeps changing. So in this case, the SQL actually allows you to do a sliding window, tumbling window. So it'll be a continuous query, and the time window that you're going to specify in the SQL will keep moving forward with the time. So as I mentioned, this is a typical data flow for Kinesis streams. You'll configure your data producers, push the data into the Kinesis stream service. It'll store the data in a streaming manner, durably and reliably. Then on the other side, you can use the tool of your choice to write your processing logic to process the data and react to the data in real time. Kinesis Firehose, on the left-hand side, it's fairly similar to Kinesis streams. You'll configure your data producers, being mobile devices, web servers, EC2 instances, applications to push data to the service. On the other side, it'll push the data into different destinations. And a few weeks back, we were pretty excited to announce that Splunk is going to be a natively supported destination for Firehose delivery. And this new feature, Firehose to Splunk, is now in beta. So if you guys are interested in testing and trying out this feature, in the end of this webinar, we will have a link for sign up for this beta access. Kinesis Analytics, as I mentioned, it's a SQL engine, runs continuously query against the data stream. You can attach Kinesis Analytics applications against the Kinesis stream or Kinesis Firehose. Then on the other side, you can emit the result into different data storage or real-time dashboard. You can also trigger a Lambda function for real-time reaction to the analysis result. For example, what you can do is to count your number of error messages that got triggered by your application. And if it breached a certain threshold, you can trigger a Lambda function. You can send notification, send an alarm, or even shut down the application or resize the cluster, and etc. So Kinesis has been in the market for 3 years. We've seen adoption across different segments, from enterprise customers to startups, using for different industries, from media to IoT to retail. And of course, TrueCar is a longtime customer of Kinesis, and David later on will have a deeper discussion about how TrueCar is leveraging Kinesis and Splunk services. All right, given that, I'll hand it over to Kara to talk a little bit about the Splunk capability for big data. Kara?
Thanks, Ray. Hi, everybody. I'm in product marketing at Splunk, and today I hope that there are 3 things that you take away from my section. One is what Splunk does and the kinds of problems that it solves. The second is what makes Splunk different and how it's super valuable to your business, or how it could be. And also how Splunk and AWS work together for our customers to be successful, like TrueCar. So if I just take a step back, we're all aware that there has been an explosion of growth of IT data center technologies. So with the advent of the Internet of Things, mobile apps and virtualization, just to name a few, there's been an increased efficiency and utilization in those technologies, but with that also increased IT complexity. And as Ray mentioned, all of those streaming data sources, there's just a lot going on. And so with that increased complexity, there are lots of disparate and silo-based solutions. And more often than not, that leads to war rooms turning to finger pointing. And teams can spend hours and hours trying to debug an issue because information is sequestered in silos. And all these issues lead to IT spending less time innovating and more time just keeping the lights on. So you might be wondering, okay, cool. How does Splunk help with that? So Splunk, if you're not familiar, is the leading platform for machine data. It digests all machine data, so anything from AWS data sources and services to servers and network, whether it's on premises or in the cloud. And Splunk enables you to then quickly analyze that data and rapidly obtain insight from it. Splunk collects machine data securely and reliably from wherever it's generated and in any format. And it does this by storing and indexing the data in real time in a centralized location and protecting it with role-based access controls. And our platform was designed around the premise of being able to consume any type of machine data, even if the format changes, which is something a relational database cannot achieve. So you can monitor both real time as the data is streaming and historical data, and you can have many lenses to the same data for basically any use case that you can think of, enabling Splunk software to turn all of that data into answers to the questions that you might have. For example, you can troubleshoot your network problems and investigate security incidents in minutes, not hours or days. and you can monitor your end-to-end infrastructure to avoid service degradation or outages. And you can gain real-time visibility and critical insights into your customer experience, such as your transactions and your customers' behavior. So there are a couple things that make Splunk different. For example, Splunk's real-time architecture, fast time to value, and the ability to scale from just your desktop for one user to the most complex data centers or cloud environments really differentiates Splunk to our 14,000 plus customers. And these differentiators lead to real business impact. They save our customers time when resolving an issue. They help our customers improve user experience. And we see a lot of cost savings and greater productivity so that our customers don't spend as much time just worrying about managing their environment and making sure that they have uptime, but they can actually innovate and become more productive in whatever it is that they're trying to accomplish for the business. So when we say we enable you to get data from anywhere, we really mean it. We offer a range of plugins, templates, and full-fledged apps that are available to help you collect, analyze, and harness data from every layer of your technology stack. So even if you're using a product that's not listed here, Splunk still does not limit you. You can still index data from that technology. And one of the key benefits of using Splunk software and cloud services is the ability to correlate machine data across silos, providing visibility across the entire application delivery and IT operations landscape. And so for the purposes of this talk, I wanted to delve a little deeper into Splunk Cloud, which is what TrueCar is currently using. And Splunk Cloud delivers the benefits of Splunk Enterprise, which is the easiest way to aggregate, analyze, and get answers from your machine data, but it's deployed and managed securely, reliably, and scalably as a service. So Splunk Cloud, there are a couple things to remember about it. One, it's a SaaS service our customers can subscribe to. Two, it is owned and managed by Splunk, the architecture, and it's a service. And three, it's already set up and ready to go on purchase. It's available once a customer forwards data to Splunk Cloud. And there are a couple things that really differentiate Splunk Cloud. It offers the fastest time to value. So you can get to go live very quickly in as early as 2 days, eliminating infrastructure requirements, enabling you to save money or time on servers, storage, and people. It minimizes the delays and change management processes for upgrades. And your employees don't have to worry about the plumbing, so they can focus on building data automation, dashboards, reporting, and alerts. It also enables you to expand your Splunk deployment quite quickly. So as you scale, we offer a 1 terabyte incremental capacity available within 2 days. And of course, you can operate premium Splunk solutions like Splunk IT Service Intelligence and Enterprise Security at the highest level of maturity and availability within weeks. And of course, I think everybody cares about this last one the most. Splunk Cloud offers a total low cost of ownership, often less than the cost of running Splunk on your own. And there are 400 plus Splunk-based apps ready for Splunk Cloud deployments with ready-to-use analytics, alerts, dashboards, and visualizations. And I always like to tell people that Splunk Cloud adheres to very rigorous security standards, something that we take very seriously at Splunk. So just to avoid confusion, what Splunk Cloud is not, Splunk is not a customer running their own Splunk license on AWS, which would be a bring your own license. That is not what Splunk Cloud is. It is not a customer managing their own architecture, and it is not a customer who is responsible for installation and setup, because Splunk takes care of that for you. So a couple things I wanted to highlight about how Splunk and AWS work together. In conjunction with AWS, Splunk developed an app and an add-on for AWS. And the app and the add-on for AWS help you gain end-to-end visibility across your AWS environment, helping you to move your mission-critical workloads to AWS with agility, security, and of course, confidence. So the difference is that Splunk add-on for AWS gets your data from AWS into Splunk, while the Splunk app for AWS provides users with dashboards, visualizations, and alerts right out of the box. And the Splunk app offers a rich set of pre-built dashboards and reports that help you analyze and visualize data from numerous AWS services and data sources, including AWS CloudTrail, AWS Config, Config Rules, Amazon Inspector, Amazon RDS, Amazon CloudWatch, Amazon VPC Flow Logs, S3, EC2, CloudFront, EBS, ELB, billing, and that's all just from a single free app that we offer with your license. And there are several ways to use the app, including for security, for operations, and for cost management. For example, for operations, you can visualize your entire AWS environment, you can view resource relationships, you can gain a playback history. And for security, you have full view of user activity, you can gain a full audit trail and detect anomalous behavior. And of course, for cost management, very importantly, you can gain a view into your resource costs, you can improve planning and utilization, and you can actually monitor spend versus forecasts. So it's very powerful, and we're very happy to work with AWS on that app. But that's not the only way to get data into AWS. As Ray mentioned, we have the Kinesis Firehose integration we just launched a couple weeks ago. And as you can see on this slide, Splunk ingests a plethora of AWS data sources and services to help you meet your toughest IT, security, and application delivery challenges. One of our newest integrations is the Kinesis Firehose, which streams data right into Splunk from Amazon Kinesis Stream, AWS IoT data, Amazon CloudWatch logs and events. And we are really excited about our ever-expanding integrations with AWS, but I want to now hand it over to David to talk a little bit about how they use Splunk Cloud and AWS at TrueCar, including his use of Kinesis for logging.
Thank you, Kara and Ray. Yeah, let me jump in here. So I'm David Geffen, SVP of the technology platform. So my team's basically enabled all of our developers here at TrueCar to basically build an automotive marketplace. Everything that sits on top of AWS, my teams basically are the interface into that. So historically, we came from a world where we actually had a data center, and we're doing basically a migration to get out of the data center and into the cloud. And so the data center inherently had lots and lots of logs. It was, full of logs that were, going basically nowhere when we first showed up here. And so we decided to go through this whole log consolidation effort to try to get a platform that would actually allow us to visualize logs and aggregate them. So initially we did that with the use of Kafka. And so Kafka would stream out, and all of the data center logs would go through that. But as we were doing the migration into AWS, we wanted to basically look at the various technologies that AWS had to offer, such as Kinesis, and then also sort of standardize the way that our applications talk to the logging service. So yeah, as we did the migration, we looked at some of the newer technologies like Docker and said, okay, well, if we're going to leverage Docker, what's the right way to basically have Docker send logs out? And so with Docker, you can actually just log to standard out and standard error. Those end up getting processed by the Docker daemon, and then we can basically take all of those log messages and then ship them off into Kinesis. So it ended up being a very straightforward and easy way to basically ship logs around. The other thing that we said is that we also wanted to get a standard logging format. I know most logs end up just being a log line. You're basically writing a message to yourself like, hey, something went wrong. But we wanted to be a little more clever there and actually put the logs into a JSON format so that we could have basically key value pairs that represented the various data within the logs. So we did all of that as sort of as prep work to really kind of get the logs into like a format that's common across all applications. So in our previous solution, we were doing everything with Elk. And so I mentioned, we had basically Kafka coming in. Elk would basically, aggregate all of the logs that we had. But this was an in-house solution that we had to basically maintain. We had a team of people that would constantly be sort of putting Elk back up. Once it would fall, once it had fallen over, it'd become unresponsive, and there weren't any third-party integrations. Right? It didn't integrate with New Relic. It didn't integrate with any of the other sort of tooling that we had around, the various metrics and application metrics that we have. So we started to look around and, and came across Splunk. And so if you look at Splunk Cloud and the way that we integrate with it, so we have the legacy data center. I mentioned Kafka again. What we end up doing is taking that Kafka stream, actually streaming it back into Kinesis. Then there's a Lambda job that basically puts it down into Kinesis Firehose and then shoves it off to cold storage. And the reason we do this is because we want to make sure that our logs aren't ever tampered with. If an attacker did come in and let's say they compromise Splunk, we're hoping that never happens, but if they did, we still have a backup of whatever logs are there, and we can actually go to that cold storage and actually see them. So we actually ship the logs to 2 different separate AWS accounts to make sure that nobody ever tampers with them. We also have the CloudWatch events that are coming back in the other way. And then every new app, so that logging infrastructure that I told you about with the Docker daemon, all of those flow directly into Kinesis and then into Splunk via the Lambda jobs. So we're looking forward to the new Kinesis Firehose integration because that'll reduce some of the complexity that we have in our overall logging architecture at the moment. So implementing Splunk Cloud was actually super simple. We use Okta for our login federation. That allows every employee at TrueCar to basically have access into Splunk. We leverage the heavy forwarder via Lambda to basically get those Kinesis streams out and then into Splunk Cloud. And then there was some instances where we had some black holes in the data center, and so we were able to use some of the the other universal forwarders and that sort of thing in the data center to get access into those sort of black holes and logging. All in all, Splunk has just a well-rounded set of tools to get your data out into Splunk Cloud. So it's a very, very useful tool set. So we've had lots of success. We've actually as soon as we had Splunk enabled, our security team went out, created dashboards. I'll show them to you a little bit later. We did integrations with our AWS billing. We were able to integrate with New Relic, and there's just a whole lot of data that now we have visibility into and aggregation and of which we didn't have before. And it's really allowed us to one, feel a little bit more comfortable with our security. We're able to see when things go sideways. We're able to iterate quicker on our development, and it's really just been a great tool. And also just the fact that we don't have to carry the burden of operating any of this infrastructure. So here's what the security team built out really quickly. So this is basically authentication insights. You can actually kind of go in, see how many successful login attempts we have, see how many failed login attempts, and this is through the integration with Okta. And here's where now you can drill in and you can see from a given IP address, these are the number of failures that have happened, and also what browsers, and really kind of dive in and see if there is a specific IP address that maybe we need to basically block at our firewall. We also have the integration with New Relic going, so you can see here's all of our applications and their overall AppDex score. If an application does go sideways, we have a dashboard that represents that. You can actually see it turn red, and then we can dive in quickly and fix those things. We've integrated it with our Jenkins build jobs, so every time our applications build, you can actually see whether the build failed or passed within Splunk. And then we've also integrated it with our internal build tools. So SpacePods is a tool that allows any developer at TrueCar to basically come in and get their own version of TrueCar. And so what we do is we use Terraform to allow infrastructure as code so that we're actually spinning up the whole entire AWS ecosystem, everything from RDS to the databases to caching. So all of that infrastructure is actually defined as code, and then SpacePods will go out and deploy that for you. So here you can see where people are spinning up a pod, their own instance of TrueCar, and you can see how many have been created. Pods typically get destroyed within 24 hours, so you can see the destroy history and everything else here. So with that, I'm going to turn it back to Ray, who's going to lead us to the end.
Thank you, David and Kara. So as I mentioned, here are a few resources for you guys to get started after this session. The first link show up on the screen is the beta sign up link with a feature for using Kinesis Firehose to stream data, being AWS data, non-AWS data in real time into a Splunk cluster. And here's a link if you're interested in beta testing this feature, get early access, you can go ahead and fill up the form. We'll send out invitation from time to time. And the second link is for you to launch a Splunk cluster from the AWS Marketplace. Super simple. Everything is being set up. You just go launch an EC2 instance with a Splunk installation already on it. And the third link is for you to learn more about the Kinesis services. We have 3 different services for different capabilities and use cases. And you can get an overview and deeper understanding of these different capabilities from this website. And lastly, more information about Splunk on AWS. It's on the Marketplace page. You can read a bit more about the Splunk capability on AWS. So given that, we'll start to pick a few questions from the audience and start answering these questions. So the first one that I got here, it's a good question saying, what are AWS and Splunk's plan for doing data security and compliance? So I can answer for Amazon Kinesis first, and I'll hand over to Kara to talk a bit about the security and compliance from Splunk side. So for Amazon Kinesis, we have a lot customers using Kinesis for streaming sensitive customer data or data with regulatory reasons needs to be encrypted or protected. So in Kinesis, actually a few weeks back, we just shipped the server-side encryption feature, which allows you to ship plain text data into Firehose or Kinesis. Then we'll encrypt the data on the server side. And you can always also encrypt the data from the client side before you send it over into the Kinesis service. And also when Firehose deliver the data into, for example, S3 destination, we also support S3 server-side encryption. So as Firehose ships the data into S3, it'll trigger Amazon S3's server-side data encryption as well. On the compliance front, we're currently working through a few different compliance that are required by different government agencies and industries. Some examples are FedRAMP, HIPAA, SOC, and PCI. So these are the focuses that we're gonna going to get certification from these compliances down the road. So you should expect to see these compliances coming up online for the Kinesis service shortly. So Kara, you want to talk a bit about security and compliance capabilities in Splunk?
Sure. I also have a Splunk Cloud Architect on, but I can take it the first part. So Splunk Cloud, as I mentioned, adheres to very rigorous security standards. We have a dedicated cloud environment for each customer, a single tenant infrastructure for compute. We also are certified in ISO 27001 and SOC 2, Type 2 certified. We also offer encryption in transit. So any data traveling over a network is SSL encrypted by default. And we also offer on AWS Marketplace an optional encryption at rest. So stored data can be encrypted at an incremental cost. So Cam, Amir, who's our Splunk Cloud Architect, do you have any other security features that you'd like to highlight?
Thanks, Kara. That's actually very comprehensive right there. With respect to Splunk, yes, everything's encrypted in flight, and also we have our compliance standards with SOC 2 and ISO 27001. So I got nothing else to add.
Thanks.
Cool. Thank you, guys. So another question that I got here is, when I collect data and send them to Kinesis from different application servers or web servers, how do I do that? Is there an agent? So the Kinesis services offer a REST API call, so you can actually use AWS SDK to write your data producer and send data into these services. We also offer a Java-based agent called a Kinesis Agent that you can install on these instances or servers. What it does is it'll monitor a local log file, and it'll manage rotation as well. So as new data gets written into these log files, it'll pick it up and forward these into Kinesis services. And the next one, I believe it's for David. So in the architectural diagram, David, you showed you're using Lambda function to process some of the data from the Kinesis streams and then forward that into Firehose. So the question is, what kind of processing are you doing on that Lambda function?
Yeah, so we actually are doing very little processing. It's really just the act of forwarding it all along. So we actually have historically done processing with Grok, which is part of the Elk stack. And so we still have some of that going on. And we've moved that out into AWS. And typically what we're doing there is we're we're reformatting some of the log lines, basically filtering in some cases, taking out logs that we don't want to end up in Splunk, things like that, and making sure that the logs are in a clean state.
Cool, thank you, David. And the next one is a good one. And the question is Splunk on AWS purely offered as a software as a service, or can I also set up Splunk within a AWS private VPC?
I'll take this one. We offer Splunk Cloud as a software as a service option, which is what I highlighted during the presentation, but we also offer you the ability to bring your own license. So if you purchase a license from Splunk, you can actually spin that up through the AWS Marketplace in a Splunk AMI that we have available. Cam, do you have anything else you'd like to offer on that?
Again, I think you covered it very well. One additional one additional point is we also offer CloudFormation templates that can leverage the Marketplace AMIs to deploy larger, bring your own license instances as well.
Cool, thank you. And the next one, can I run machine learning capabilities on a streaming data pipeline? So good one, the answer is yes. From the 3 Kinesis services, one of them is called Kinesis Analytics. If you recall, it allows you to run SQL queries, a SQL engine on top of data stream. And it's also integrated with multiple machine learning algorithms, and we're going to keep expanding that list. So today, a very popular algorithm we have in the Kinesis Analytics service is anomaly detection. It's unsupervised, so you do not need to provide any training beforehand. As the data points keep coming in, it'll score an anomaly score on each of the data point, and you can trigger an alert, trigger an action if the anomaly score goes really high. So we actually have one airline customers, and because as you guys know, all the different airlines, they have a pricing system to decide how much they want to price for a particular ticket on a particular flight, and that number keeps changing depending on different market situations. And from time to time, there's an anomaly happening in the pricing engine, so you will have an awfully low price on a particular ticket, and that triggers a lot of revenue loss for the airline companies. So they're actually using Kinesis Analytics, an anomaly detection algorithm, to collect all these pricing data over these different websites and also the airline's own pricing system. As soon as it detects, hey, based on all the marketing condition, all the inputs, this price looks very abnormal, they use the Lambda function to bring that ticket and bring that price down temporarily and trigger an alert. So the human being will get involved, review the price, and fix that issue. So that's a very cool use case, I think, that really helps that airline save a lot of costs, and they do not need to have any streaming data expertise, machine learning expertise beforehand. Everything's already built in, and you just use a SQL statement or a SQL template for that. The next one I think is for Kara for Splunk. For application and analytics, what are the typical use cases you see Splunk customers do to analyze their application logs and patterns?
Sure. I did actually want to invite Cam to also talk about machine learning for streaming data real quick in Splunk.
Sure, let's do that.
Is that okay?
Absolutely.
So the answer can actually fall with both questions, actually. So with respect to the machine learning toolkit that we actually have integrated into the AWS app, it powers a lot of our insights that we have. These insights are basically taking a look at your data from AWS and telling you, hey, you might want to remove this security group, you might want to upgrade or downgrade this particular instance based on usage and patterns, and very simple patterns, at least in the beginning with the AWS app. But it also starts looking at other things such as potentially security anomalies or billing anomalies and alerting you on that information as well. So that leads to the next question, which is what do people normally use Splunk for? And obviously being able to look at their AWS environment, and obviously what TrueCar has done as well, looking at application logs. It's a very diverse platform for machine data. So you have people looking at it from a security standpoint, but you also have people looking at it from an application standpoint, and then you have people looking at it from IoT and other very ingenious ways of looking at data. So it's up to your imagination. So you're only limited by your imagination of what you can do with this data.
And what we see a lot of customers using specifically around applications are around application delivery, as well as application management, or something we're calling application performance analytics. So not only are we seeing a lot of DevOps use cases and developers, using Splunk to monitor their entire a dev build pipeline, integrating all of the tools that they're using to make sure that their code releases are happening as productively as possible, because we integrate across that entire tool chain. But we're also seeing, once those applications are in production, to be able to monitor how they're performing is super important. And so we see a lot of people in ops roles using some APM tools in conjunction with Splunk, because we not only take that deep application data into account, but we also enable you to correlate that data across the entire tech stack to see where are the failure points. Because most infrastructure issues that you see are not only going to be happening in the application itself. So those are two other areas that we see a lot of our customers using Splunk specifically for applications.
Cool, thank you, Kara. And the next one, I think it's for David. It's a good question. So the question is, how long did it take for TrueCar to implement this solution, this architecture from the very beginning until where you are right now? So I think that's sort of wanted you to talk a bit about, how long does it take, how much resource you spend, and how does it compare to your previous solution?
Yeah, that's a good question. I think, generally when we first started, we spent a lot of time really kind of tuning and getting Kafka up and running in a place where it was actually able to process all of the logs and get them into Elk. And so I want to say it was probably on the order of months of ops people really kind of diving into that system, making sure that it was doing the right things, tuning it, hand-holding it to basically get the logs to where they needed to go. And then when we moved into AWS, it was much different, right? So with Kinesis, we were able to basically within, I don't know, it was like 15 minutes, basically spin up a Kinesis stream and start writing data into that. And it's a managed service just like Kafka, and so it just took that burden completely away. And then once we had Splunk Cloud, it was like, okay, now we're just going to forward those messages into Splunk Cloud, and we just turned that pipe on, and it just went. So I think generally, if you look at what we had to do in the data center versus what we had to do in AWS, it was order of magnitudes difference.
Cool, thank you, David.
Yep.
And the next one, I think the audience is interested in the security use case with Splunk. So, Kara, can you talk a bit more about what are the security use case of the Splunk, and what are some of the customer examples that you can share?
Sure. I actually sit on the IT side of the house. So my colleague in security might be a better fit for this. But we see a lot of security use cases using Splunk. So Splunk, the platform, just Splunk Cloud or Splunk Enterprise, we offer a lot of capabilities around security investigation. So reducing the time it takes to detect, analyze, and resolve any threats to your environment. We also offer fraud and compliance use cases, and we actually offer a premium solution called User Behavior Analytics that specializes in machine learning around making sure that the behavior in your environment is appropriate. And then in terms of our SIM product, Enterprise Security, that has a very deep UI and use cases around making sure that any kind of anomaly detection that you find, or breaches to your firewall, or using basically all the same data that you would for infrastructure monitoring or application performance analytics, but making sure that there's no nonsense essentially happening in your security posture. And it's really helping you beef up how protected you are against threats that could be anything from malware to a malicious hacker, or maybe a data breach or a leak that you could have. And you see a lot of this happen in the news, like the Equifax breach. And so, making you prepared for things that could happen that would threaten the security of your business is really what Splunk for Security specializes in. And Cam, I don't know if you have any addition. We also offer the ability to integrate with new AWS security services like Macie, in addition to ones like CloudTrail and Inspector and Config Rules. And we also offer something called the Adaptive Response Initiative, which is a collection of partners, including AWS, that enable you to take specific actions based on certain use cases or data sources that you would want to resolve in real time.
Cool, thank you, Kara. The next question is, can you talk a bit more about the integration between Kinesis and Splunk? So I can speak to that. So the particular integration is between the Kinesis Firehose service and Splunk. So the Kinesis Firehose service allows you to stream data from different data sources and transform the data, then get that into the destination. So the integration between Firehose and with Splunk is leveraging Splunk's HTTP event collector. And when we build a reliability layer on top of the HEC endpoint so that all the data will be acknowledged after index versus after receiving the data. And you can use Kinesis Firehose to actually stream data from different AWS data sources. For example, today we support streaming data from CloudWatch logs directly into Kinesis Firehose service, which means you can do any log data within CloudWatch logs, such as VPC flow log, your Lambda function log, or your custom log, and get these data streamed through Firehose into Splunk directly. Firehose service is also integrated with CloudWatch events. And within that CloudWatch event service, we have CloudTrail data. So all the API call monitoring log data, EC2 change events, S3 events, all these data you can stream into Splunk in near real time through the Firehose service. We're also integrated with AWS IoT service, which means if you have IoT use cases, you can use MQTT protocol to speak to the AWS IoT service, collect sensor data from your IoT devices, and then stream through Firehose into Splunk. And we're going to keep expanding the list of these supported data sources. And the integration, the point is, if we want to make it super easy for you to be able to analyze all these data source data using Splunk. So the user experience we want it to be is, say, for example, we want to analyze VPC flow log using Splunk cluster. You just go to Firehose, set up VPC flow log within CloudWatch as a data source, then choose a Splunk endpoint to stream the data in. On Splunk side, we have this Kinesis Firehose add-on, which is fairly similar to the current AWS add-on. It'll have the different data source type from AWS log data. So if you choose VPC flow log, the Splunk cluster will just parse the data and convert that into a readable schema and an analyzable schema. And you can run search, you can run dashboard right away. So we're pretty excited about this integration for you to combine the capability of streaming data on AWS and the rich analytics capability on Splunk. So I encourage you to go ahead and sign up for the beta program if you're interested in this integration and see how it works. And we're working hard to get this GA and get it to a broad set of customers out there. Given that, another question for David, I think we'll take this as the last one for David, then we'll conclude today's webinar. So the question is, has TrueCar tried any of the analytics services within the Hadoop ecosystem, like MapReduce or Spark?
Yeah, so we actually do use MapReduce. We do use Spark. We tend to not use them for logging, however. So we do analyze clickstream data. We do analyze a lot of our sort of dealer feeds and pricing feeds and all those sorts of things. They all end up in S3, and then we'll actually use MapReduce to do transformation there, aggregate the data there, and actually provide and actually create Elasticsearch indexes that end up eventually powering our websites. So we do use it, but we don't use it for logging.
Thank you, David. Yeah, I just want to add to that, because as I mentioned, we think streaming technology versus spatial-oriented technology, which Hadoop is a big one, we think them are complementary for different kind of use cases. And eventually, I think you'll need both different capabilities for different kind of use cases. Great. Given that, I want to first thank David and Kara for presenting the webinar today with me, and also want to thank all the audience to joining with this webinar session this morning. Thanks again for joining us for the webinar this morning. Thank you, guys.